Hi everyone, welcome back. Let's write some more Leetcode today. Today we are solving longest strictly increasing or strictly decreasing subarray. I will go over two ways to solve this problem, but we'll only go over the coding for the optimal solution. If you're only interested in the optimal solution, then feel free to skip to the timestamp. So the problem states that we are given an array of integer nums, and we want to return the length of the longest subarray of nums, which is either strictly increasing or strictly decreasing. So strictly just means only, meaning that equal to doesn't count. It only counts if it's increasing or only if it's decreasing. So if you look at these two examples, the output of this one is 2 because 1 to 4 is strictly increasing and 4 to 3 is the pattern of strictly decreasing. This breaks the pattern because being equal doesn't count. And right here it also has a length of 2. So the longest subarray that we have is 2. And for here they're all equal, so the longest subarray is 1. So how can we solve this problem? One way that we can solve this problem is that we can look at each index, and at each index we can look for the maximum subsequence that it can make. So if we look at this index, it can make an increasing of 3, which is right here. Right here it makes an increasing of 2. Right here it has a subsequence of decreasing of 2, which is right here. And right here it has a subsequence of 1. And over here, it has a decreasing subsequence of 2, which also goes here. And right here has a subsequence of 1. And then obviously the result is 3. That's the longest than 1 that we found. The time complexity of this method would be O of n squared, because we have to look at each index, and at each index, the subsequence can go to all the way towards the end. So the time complexity is O of n squared, where n is the number of elements in the array. There's actually a more efficient way to solve this problem, and I'll go over that one right now. Another way that we can solve this problem is that we can use this state variable. So the state variable can either be increasing, decreasing, or it could be neither. So as we compare, if the state has changed from the previous state, then we need to reset the length to 1. If this new state is increasing or decreasing, then we should add 1 to it. If it is neither, then we just keep it at 1. And each time the state changes, we should update the result. So let's go over this example. I added a 5 here so I can make the example a little bit more clear. So first we compare 1 and 4. Change the state to increasing, and the length is 1. We need to update the result first before we change the length. And now we need to add 1 to the length, so the length is 2. Go to the next one, 4 and 5. The state is still increasing, so we just add 1 to the length. Then now go to the next one, 5 and 3. The state has changed to decreasing, so we need to update the result. So the result is 3. And then the length, we need to reset it to 1, but add 1 to it, so now it's 2. Now we go to the next one. The state 3 to 3, so now it's neither increasing or decreasing. We need to update the result, still 3, but now the state changes to neither. Reset the length to 1. And now we go to the final one. It's a decreasing state, so the state changes again. Update the result, but it's still 3. And then reset the length to 1, even though it's still 1. But now we need to add 1 because it's a decreasing state, so now it's 2. And the time complexity of this approach would be O of n, where n is the number of elements in the array, because we have to look through each element. And the space complexity would be O of 1, because we're not using any extra space. So now let's get to the coding part. So we set the initial result to 0. The beginning state would be neither. And the initial length would be 1. Now write the for loop for I in range length of nums minus 1. If the number of I is less than number of I plus 1, so if it's the increasing state, we need to check if we are changing a state. If the state is changing, then we need to update the result and reset the length to 1. And then afterwards, we can just add the length and set the state to increasing no matter what. Now if it is decreasing, so if nums of I is greater than or equal to nums of I plus 1, we need to check if the state just changed to decreasing. So if state does not equal to decreasing, that is the case, then we update the result and reset the length to 1. And we can add length to 1 no matter what and set the state to decreasing. Else, if it's neither, then we just update the result, set the state to neither, and reset the length to 1. Other than that, and we can update the result at the very end, and then return result. Alright, let's see if it works. Okay, perfect. I just realized that you could put line 18 and line 12 inside the nested if statement, but either way works. Okay, Thank you all for watching. I hope this was helpful. If you have any questions or comments, feel free to leave it down in the comment section. And I hope to see you all again soon.